notice, and this is a typical copyright. We are continuing with the mathematics syllabus for CSEC 2018 to 2027. Once again, schedule of videos. By the end of this month, September 2024, I'm hoping to have all 32 videos published from section 1, and then in October, 13 to 15 videos on consumer arithmetic and so on, November, December. By January 2025, we will be dealing with statistics. Then February, algebra. March, relations, functions, and graphs. April, geometry and trigonometry. And then finally by May, mid-May, I will have the videos for vectors and matrices available. This section, of course, forms the foundation on which the rest of the syllabus is based, and it is work that students are supposed to be able to do by the time they finish Form 3 or Grade 9. So in the last video, video 8, we looked at some prerequisites needed in order to add, subtract, multiply, and divide fractions. Now in this video, we are actually going to add, subtract, multiply, and divide fractions. But make sure you understand those prerequisites. So this was what we did in the last video. Now we are here. So we did the prerequisites. Make sure you know them. Now let's add and subtract and multiply and divide fractions. Consider a situation where workers marked off and cut out a tile into 4 equal parts and use 3 of those equal parts. So if this is a tile, it's cut in 4 equal parts, and then they use those 3, so 1/4 or a quarter of that tile remains. Later, they marked and cut out identical tiles into 6 equal parts and use 5 of one of those. So another tile, 6 equal parts. This time, they use 1, 2, 3, 4, 5, and this part up here remains 1/6. Maria collected the 2 leftover pieces, that is to say, this 1/4 and this 1/6, and wondered what part of an original tile she now has. How much of this tile would those 2 make up? In effect, we are going to add those 2 fractions. So we want to add a quarter and 1/6. For those who don't know any better, the temptation is there to just add the 2 digits on the top, like that, and put it over the sum of the 2 digits below, like this. So they would say a quarter plus 1/6 is equal to 2/10, which is wrong. That's not how this is done. What we need to do is find the LCM of 4 and 6, and you know how to do that by now. And we get 12. We take that 12 and put it down here. And now we say 4 into 12, and whatever answer we get, we will then multiply the numerator. So 4 into 12 would be 3. 3 ones would give us 3. Bring down the plus sign. 6 into 12, 2, 2 ones, 2. At this point, we have expressed a quarter as 3/12, and we have expressed 1/6 as 2/12. In other words, those two fractions now have the same denominator. And now we can add the numerator and keep that one denominator, not like what was done here. You could only do that if the denominators are the same. So 3 and 2, 5 over 12. Now, this is what you do. And in order to do that, you make sure that the two fractions or three fractions that you are dealing with, that they have the same denominator. And to do that, you use this LCM and this system that you see here. So how much tile does she have? 5/12. So you take another tile and divide it into 12 parts, divide a tile into 12 parts, and take out 7 of those, 2, 4, 6, and 1, 7, take out these 7, and what she is left with is 5/12. 1, 2, 3, 4, 5/12. So that is amount of tile she has when she combined these two pieces. Keep in mind that when you add or subtract fractions, they must represent parts of identical items. So let's look at another example. If in this case, you have 4/9 of a leftover tile here, and you have 2/3 of a leftover tile here, how many would those two make up in terms of a complete tile? Again, do not add 4 and 2, 6, and then add 9 and 3, 12. Do not do this. In order to add the numerator, we need to make sure that the denominators are the same. And to do that, we will find an LCM. And we get the LCM is 9. And we really didn't need to do that because, you see, 3 is a factor of 9. So we didn't need to find LCM. If 3 is a factor of 9, then 9 is the LCM. All right, so 9 LCM. 9 into 9, 1. 1 times 4 is 4, plus 3 into 9, 3. 3 twos, 6. So at this point, well, 4/9 is 4/9, but 2/3 is now 6/9. So those two fractions now have the same common denominator. So you could add the numerator. So we add 10 and 9, and we reduce this because it is an improper fraction. And we get 9 into 10, 1, remaining 1 over 9. And that is our answer if we were to add these two pieces of tile. So in effect, the amount of tile is 1/9, that's 1/9, plus a complete tile, this one here. So if you add 4/9 and 2/3 of the identical tile, you will get 1 and 1/9 equivalent. If you find this video useful and interesting, then please like and share, that is, like and share. And you may also consider subscribing to this channel. Now that we understand the concept of adding fractions, we can proceed with just the numbers. We don't need to have the tiles and the drawing. That's a bit tedious. So let us say you have 4/5. You know what that means. And then 2/3, and then 1/6, and you want to add those. We will find the LCM, but since 3 is a factor of 6, we don't need to put 3 over here. So we will just deal with 5 and 6. And we find the LCM. and we come up with 30. So we draw a line like that and we put the 30 down here. Now remember, what we are trying to do is to express each of these fractions up here with a denominator of 30. So 5 into 30 would be 6. 6 times 4 would be 24. Put that there. Plus 3 into 30, 10. 10 to 20. Put that there. Plus 6 into 30, 5. 5 ones, 5. So at this point, 4/5 is the same as 24 over 30. 2/3 is the same as 20 over 30. And 1/6 is the same as 5 over 30. So now these fractions up here, they all have the same denominator. Of course, the numerators change accordingly. In this case, we are now able to add the numerators. So we add 24 plus 20 plus 5, we get 49 over 30. This is an improper fraction, so we carry it to a mixed number. 30 into 49, 1, remaining 19. And this is our answer. Let's look at another example. This time we are dealing with mixed numbers. 4 and 4/5 plus 2/3 plus 1/6. This is basically the same question we did just now, except now we have a 4 here. And we could have had a 1 here and so on. So the LCM we found out was 30. Draw a line like that. Bring down that 4 because that 4 is a whole number. Put the 30 under here. And we do the same thing we just did. We get 24 plus 20 plus 5. Recall when we added these, we got 49 over 30. But we still have this 4 in front here. That is a whole number. So 4 plus 39 over 40. When we work out 39 over 40, as we found previously, we got 1 and 19 over 30. So now we are going to add 4 and 1 and 19 over 30. So we add the whole numbers. 4 and 1, 5, and 19 over 30. Let's look at another example. This time is the same numbers, the same fractions, except we now have a minus sign here. So we find the LCM and we get 30, like that. 5 into 30, 6 times 4, 24, minus now 20, plus 5. So remember that is a plus 24. So we could go from left to right, or we could take the two pluses together and then take away the minus. So 24 minus 20 is 4, plus 5 is 9. Or you could say 24 plus 5 is 29, minus 20 is 9. Either way, you still get 9. So we get 9 over 30. We can reduce that, and we get 3/10, which is our answer. Now let's look at this one. 2 and a quarter plus 3 and 1/8 minus 1 and 3/4. Well, first of all, we deal with the whole numbers. 2 and 3 would be 5, minus 1 would give you 4. Let's look at our LCM. In this case, you don't actually need to do the LCM because the 4 will go into 8. So the LCM is actually 8. But if you want to find it, you could go through the process like this, and you get the LCM is 8. As I said, you really didn't need to do this, but it is 8. So 4 into 8, 2, 2 ones, 2. 8 into 8, 1. 1 times 1 is 1. 4 into 8, 2. Bring down that minus sign there. 2 threes, 6. So at this point, we have 2 plus 1, 3, minus 6 over 8. But we have a whole number here. So obviously, we can subtract 6 from 3. So we will take 1 from that whole number there, which will leave us with 3, which will leave us with 3. But that 1 that we took from there is actually 8 eighths. Whatever this denominator is, if the denominator had been 10, that one will be 10 tenths. If the denominator had been 12, that one that we took from here would have been 12 twelfths. So that one is actually 8 over 8. And this 8 here goes up there. That 8 is still this 8. So now we have 8 plus 2, 10, plus 1, 11, minus 5. And of course, we still have this 3 as a whole number here. So we put back the 3 as a whole number. And 8 and 2, 10, and 1, 11, minus 6 is 5 over 8. One more example, and this time we don't have any whole numbers to take from. So our LCM is 30. Put the 30 down there. 5 into 30, 6 times 2, 12, minus 3 into 30, 10 times 2, 20, plus 6 into 30, 5 ones, 5. All right, now we have a situation here. 12, this is a plus 12, plus 5 is 17. So 12 plus 5 is 17. And from that 17, we want to subtract 20. We don't have any whole number here to take and make it 30. So what we will have to do is just work with what we have here. 17 minus 20. We have unlike signs. We will subtract and retain the sign in front of the larger number. So we get negative 3 over 30, which is actually negative 3 over 30. We reduce that 3 over 30 and we get 1/10. So the answer to this question here is negative 1/10. And that is all you need to know about addition and subtraction of fractions, mixed numbers. Now we will deal with multiplication and division of fractions, mixed numbers. So let's go back to those tiles. Workers mark off and cut a tile into 4 equal parts and use 3 of those equal parts. So what remains is 1/4 or a quarter. Now, this was done on 6 identical floor tiles in an apartment building. So 6 such tiles. Tyler collected the 6 identical leftover pieces and wondered how much or how many of the original tile he has. So how much or how many of that? So we are going to multiply a quarter and 6 like that, or multiply a quarter by 6, which is really 6 over 1. We just set it up like this, that it would look uniform, like a fraction. At this point, we will reduce any numerator with any denominator by a common prime number. So we can divide that 4 by 2, and we get 2, and we could divide this 6 by 2, and we get 3. We can't reduce any more numerator and denominator, so we will multiply everything at the top, which is give us 3 ones 3, over, multiply everything below, which would give us 2. This is an improper fraction. We will carry it to a mixed number, and we get 1.5. So in effect, Tyler had half of this tile plus a complete one. That's 1.5 such tiles. Now, LCM is not required for multiplication and division. Let's say that from each of those 6 floors, 2 3/4 tiles were left over from each of the 6 floors. 2 3/4. That's 1 3/4. 2 3/4. How many equivalent tiles would Tyler now have? So we are going to multiply 2 3/4 by 6. We write it as 6/1. Now there is a hard way of doing this and there's an easy way of doing this. Let me show you the hard way first and then the easy way. You can say, well, from each floor he has 2 complete tiles, so 6 times 2 would give us 12. And then from each floor he has 3/4 more tiles, so 3/4 times 6. Well, we can reduce that 4 and that 6 like this, and he has 9/2 more tiles. This 9/2, of course, would give us 4.5. So that 9 divided by 2 would give us 4.5. 4 plus this 12 would give us 16, and of course the half. Okay, that is the hard way. There is an easier and better way to do this. So let's look at that. First, express any mixed number in the question as an improper fraction. So 4, 2 is 8, and 3, 11. So 11/4, that is the same as this. Multiply by 6/1. Now we will reduce any numerator with any denominator by using prime numbers. So that 4 can be reduced by 2 to 2, and this 6 can be reduced by the same 2 to 3. Can any more numerator and denominator be reduced? No. So at this point we have 33/2, and we carry that to mixed numbers, and we have 16.5, which is the same answer we had previously when we were doing it the difficult way. Now let's say that Tyler collected 2 3/4 tiles, and he wants to divide that into 6 equal pieces. What is the equivalent that one of those 6 pieces would be? So what is the size of each of the pieces? So he has 2 3/4 tiles, as you see up here. 1, 2, and 3/4 tiles. He wants to divide that into 6 equal pieces, or the equivalent of 6 equal pieces. So what will be the size of one of those pieces? In effect, he has to divide 2 3/4. He has to divide 2 3/4 by 6, not multiply this side. So what would be the size of one of the pieces? So 2 3/4 divide by 6. We set it down like this for a particular reason that you will find out in a little while. So we're dividing by 6/1. Invert the fraction that is immediately to the right of the division sign and change that sign to multiplication. So we will invert this and change this division to multiplication. Of course, we have to carry that to an improper fraction. Now, that is to say, to divide by 6 is the same as multiplying by its inverse. So 11/4 multiply by 1/6. Now, we cannot reduce these two denominators. We could only reduce a denominator and a numerator. So there is nothing here to reduce, and we are left with 11/24. So in effect, one of the pieces would be 11 over 24. So let's take one of those tiles, divide it into 24 parts, take out 13, and we are left with 11, 2, 4, 6, 8, 10, 11 out of 24. So that is the size of one of those 6 pieces. Let's look at this one. 2 3/4 times a half divided by 3 1/8. We carry that to an improper fraction, 11 over 4. This remains as multiplied by a half. This here we will also carry to an improper fraction, divide by 25 over 8. Now remember what we said about inverting this fraction that is immediately to the right of the division and changing the division into multiplication. So we have that, and now we have multiplied by 8 over 5. Can we reduce any numerator with any denominator? So yes, that 4 there, 2 into 4, 2, and 2 into 8, 4. We can further reduce that, 2 into 2, 1, and 2 into 4, 2. Then there is a 2 here and a 2 up there, 2 ones, 2 ones. We can't reduce any more denominator and numerator. So we multiply everything at the top. 11 times 1 times 1, which would be 11. And we only have 25 below. So the answer to that question is 11/25. And that is all you need to know about multiplication and division of fractions and mixed numbers. So in this video, we were looking at this part of the objective: add, multiply, subtract, and divide fractions. And that brings us to the end of video 3B of objective 3 in section 1.